Hi everyone, I am Hrishikesh, and me and my teammates Balaji and Hardik are going to present our presentation on the research paper titled Towards Empathetic Conversational Recommender Systems. So, Conversational Recommender Systems (CRS) are uses multi-turn dialogues to understand the user preferences for recommendations, combining the item suggestion with a natural response generation. So, an example of this is the recommender system asks the user what genre of movie do he like. The user replies with he likes romantic movies. So the recommender asks the user if he had seen the movie Midsummer's Night's Dream, which user replies with he did see it, but he did not like it very much. So conventional CRS response will be like, what about Romeo and Juliet? This does not capture the emotions of the user, but in the case of an empathetic CRS, the reply is like, you should watch the romantic love movie Magic in the Moonlight. This response expressed the emotions also, which is, I declared this movie as my favorite. It's Woody Allen's best work, in my opinion. Everything was beautiful and perfect. So in the case of empathetic CRS, the recommender system captures the emotion and also expresses it. So right now, many CRS rely on predefined responses and overlook the user emotions. Also has a limited ability to fully align with users' emotional engagement. So an ECR framework adds empathy to improve user satisfaction and accuracy in recommendations. So see the CRS system can be modeled to understand and respond to the user needs across the dialogue turns. So it takes dialogue history up to the tth term that is denoted by d of t minus 1, which contains a sequence of utterances from both the user and the recommender. And this sequence, dt minus 1, captures the prior exchanges and form the context for future recommendations. A knowledge graph G, such as Wikipedia, enriches the system's understanding of entities mentioned in the dialogue. At each turn T, this CRS system performs two main tasks, that is item recommendation, in which it selects a set of items relevant to users' expressed interest, which are derived from the knowledge graph entities E, and response generation. It creates a dialogue response U, which is contextually relevant and it can integrate emotional alignment with user preferences. So the CRS relies on a structured backbone framework inspired by UniCRS, merges the recommendation and response generation in a unified approach using a PLM. This framework has three main modules: semantic fusion, response generation, and item recommendation. In the semantic fusion, integrates the dialogue semantics with knowledge graph information and aligns the entity and word embeddings. Uses a bilinear transformation to produce fused word representation and fused local entity representation. In response generation module, it generates responses using a recommendation specific prompt. These prompts includes fused word representation, your soft token for generation, and dialogue history. So the items mentioned in this response are then masked to ensure the relevant recommendations are filled after the response. In the item recommendation module, after getting a response, the system uses a recommendation prompt to finalize the item suggestions. Here, both the response generation and the item recommendation process use cross entropy loss for optimization. So, but why is empathy crucial in CRS? So, empathy bridges the gap between your user's expectation and system responses, recognizing and expressing emotions. This aligns CRS response more closely with user needs and enhance the natural conversational feel of interactions. But in the case of conventional CRS, they often misinterpret emotional cues in dialogues, leading to recommendations that might ignore the user's sentiments. For example, let's say when a user expresses a dislike for an item, a traditional CRS will recommend a similar item, failing to capture the user's negative sentiment. So what ECR does is it captures the user's emotion during the dialogue to refine preference modeling, ensuring recommendations are contextually aligned with user's feeling. And also ECR generates responses that convey empathy, making the interactions feel more human and engaging. So empathy in item recommendation integrates the user's emotion with entities and dialogues to make recommendations that reflect user preferences accurately. And empathy in response generation fine-tunes a language model to align responses with users' emotion using emotional review data. The ECR framework basically looks like this. It has two main modules, two key modules. The first is emotion-aware item recommendation, is used for better user preference understanding. And the second module is emotion-aligned response generation, used for engaging the conversations. My friend Balaji will take from here.
Hi everyone. Now we'll be looking into the item recommendation and the prompt generation part. So in every stage of our data flow, we are infusing emotions. So this item recommendation part consists of two major steps. One is emotion aware entity representation. The other one is feedback aware item reweighting. Emotion aware entity representation is nothing but while vectorizing your entity into a vector of numbers, you also infuse the emotion as another vector and concatenate both. And feedback, our item reweighting, basically is reiterating over the same vector so as to get the changing user input and fine tune it for the particular emotion the user uh, expl explains us. Now coming to the entity representation part, there are two types of entities, local entities and global entities. Local entities come from the current dialogues ongoing with the user. Global entities come from the training data. Now the local entities may be changing. User may be inputting several different agent entities along with changing emotions. So we have to capture all those along with the trained data with the entities and emotions. We'll be vectorizing these and using it to train fine tune our language model. Coming to the local emotion entities, for each entity, will be having a particular emotion associated with it. Now, we cannot surely say that the only one single emotion is associated with a single entity. There may be multiple entities associated. So we are weighing it alongside a probability, which is P of I. And the final emotion we'll be getting is a weighted average of all the emotions associated with that entity. Now, the global entities also work the same, but here we are fine tuning all the training data with our new user input and the emotions. Now, coming to the item reweighting, uh, here we adjust the recommendation relevance by scaling item weights based on user feedback, like, dislike, not say. So in our data set, we have around 9 different emotions. So we'll be having 9 different possible um, elements in the emotion set for each user feedback, which is called an utterance. Now the loss, it's basically a cross entropy loss, which has the weight based on feedback of for item ik along with the probability for recommending item ik. For example, if you recommend an item I with a high probability and the feedback is very negative, so your loss will be more. So that's why we have a negative sign here so as to flip the sign. Now we need to prompt our language model. So we need to infuse as much as emotion we need into that single prompt. What all do we use? Soft tokens. Soft tokens are basically the tokens which may evolve over time in future based on user needs, and the dialogue history, which is the entire dialogue until a time t, and the response, uh, which our system responded earlier. So here we are getting two major benefits. One is precision, which ensures recommendations align closely with user emotions and preferences. and context awareness, which incorporates ongoing dialogue for relevant and responsive recommendation. Now coming to the response generation part, we have two major components. One is the generating the prompt, and the other one is the response generator. Now, generating prompt leverages emotion-infused entities, which we talked earlier about how we are infusing emotions into each and every part of your data flow. And then the generator, which fine-tunes a language model to produce more empathetic responses. Now, the response generation process prioritizes user sentiment and contextual knowledge to enhance the recommendation conversations. Coming to the generation prompt, we construct a prompt that includes emotional and contextual information, enhancing a relevance and grounding response. Here we have a prompt structure which composes of knowledge entities. These are the entities which are in the runtime, which the user has mentioned, and which are also related to the entities which the user wants. And the knowledge triples. So the triple basically contains a head, relation, and a tail. So, for example, we take a movie, say Godfather. The movie Godfather is the head, and the description of the movie is the relation. And the tail is basically all the references, which may contain the name of the director, the genre of the movie, and the actors in that, so that we can link more and more information to the end of a particular entity. So, this creates a separate knowledge graph, which helps us in tailoring to the user needs. Coming to the response content, after generating a response, we'll produce an item name along with the recommendation response to the user. So this is the combined data which we'll be generating. Coming to the actual generator, the generator has a data source, which is a set of emotional reviews that are highly enriched in emotions and human sentiments. And the loss function we are using is a cross entropy loss with a probabilities of uh, generating each word based on the previous words and the current prompt which are inputting to the language model. Coming to data enlargement, here here we get to see the process of how we trained our model. Here we basically used redial, which is recommendations dialogue data set, which has thousands of conversations along with millions of utterances. So each utterance is basically text by user. For example, a user says, I like Godfather a lot. So we have 9 different emotions. So like may have a probability of zero point 0.9, curious may have 0.001, happy maybe 0.005, and negative may be very less. And for example, if you see the utterance level emotion set, it contains all the emotions which are above a certain threshold. For example, like, curious, grateful. All these may be present in the utterance level emotional set of the particular utterance. And the associated probabilities are for the corresponding emotions. And here we are representing the emotions for each entity in the same manner as we did above. This is for the output. I'll be handing over to Hardik. He'll take in.
Yeah, thanks, Balaji. So coming to the experiments that the researchers performed. So till now we saw all the technical details as to what the researchers were trying to inculcate in the model. So what a simple model does is that we were trying to inculcate emotional emotional intelligence as well into the recommendations that were being provided by the model. So coming to the experiments, there were three main questions that the researchers wanted to address. First was, does ECR, that is emphatic conversational recommendation, learn user preferences by capturing their emotions to improve the accuracy of recommendation. That is, it is capturing both emotions as well as having a decent recommendation accuracy. Second is the ECR capable of expressing emotions in the responses that it provides. And the last one is how does each component of ECR contribute to its overall performance? So next slide. Yeah, coming to the data set, as Balaji said earlier, they used the Readal data set, and it basically comprises of 10,006 multi-turn dialogues. That is two-way dialogues between having a two-party structure, and it had utterances from 51,699 movies, allowing diverse conversational scenarios. And the feedback types comprised of labels for every item, including like, dislike, and not say, capturing nuanced user sentiment to inform future recommendations. And coming to the emotion data annotation, the emotional labels were selected utterances assisted in improving emotional alignment with user preferences. Next slide. So the researchers also compared their model with other state-of-the-art models that were present, a few of them being KBRD and uh, KGSF, RevCore, and UniCRS. So out of this, two of them were to test the recommendation accuracy, to compare the recommendation accuracy, and RevCore was to test to review the emotional relevance of the responses that were being produced. And UniCRS was basically to compare prompt-based learning with pre-trained language models to unify item recommendation and response generation. Other models that were also used for comparison were Llama 27B Chat and GPT 3.5 Turbo, which provided with full dialogue history for consistent response generation, ensuring a fair comparison to the model that was being compared. Next slide. Yeah, so end of day, we are trying to test on two main things that we are trying to see if our model is able to evaluate well on. One is the item recommendation that, as I said, if our model has a good recommendation accuracy, they use metrics like recall and AUC, measuring the system's ability to suggest, relevant items. And as for the responses, they looked at emotional intensity, emotional persuasiveness, logical persuasiveness, and informativeness and lifelikeness. So the responses should be lifelike. They should not be dull and boring. Yeah, next slide. Yeah, these are the technical details as for the model parameters that were used. So an embedding size of 48 were used for emotion labels, facilitating fine-grained emotional representation. Batch sizes of 128 and 16 for response generation. As for the optimization, an Adam W optimizer was used, and threshold was also set, and feedback weights were used and assigned, as in for here you can see for like 2.0 was set, for dislike 1.0, and for not say 0.5. And models were also fine-tuned to maximize the recall and AOC metrics, emphasizing accurate preference modeling. Next slide, please. These were just the results, as you can see. You can see that ECR improves upon models like UniCRS, especially in ranking relevant items higher and matching user feedback better. Other than that, ECR score also showed that it could recommend items that align better with user emotions, making it more satisfying for users. And yeah, these are just the results and comparison of other models as well. You can see Llama 2, GPT 3.5 Turbo, and you can see ECR ranks higher compared to the other in most of the parameters like AUC and RT at 10. Next slide. Yeah. So before I had said that there were three questions that the researchers were trying to address. So here the first question was addressed with the objective of assessing how well ECR aligns recommendations with users' emotions, comparing against other baseline models and evaluating the performance, as you could have seen in the earlier tables. Again, the metrics that they use were AOC. That is, it measures the model's ability to prioritize positively rated items over negatively rated ones. And other than that, there was a recall. It tracks if correct items appear in the top end recommendations for the recall at N. And then recall true basically focuses on positively rated items, measuring true positives for like feedback. So there were three feedbacks that we were measuring: like, not like, and not same. And as for the results, ECR achieved six. Oh yeah, previous slide. I'm not done. Yeah. So as for the results, we could see that ECR achieved higher, 6.9% higher over UniCRS, as you could see previously. And again, for RT10 as well, it showed higher than UniCRS and other state-of-the-art models. So these metrics showed its capacity that it performs better. Yeah, next slide. Again, coming to the question two, it basically evaluates its ability to generate emotionally aligned responses. So this is more of the response part and not understanding part. So metrics like emotional intensity, emotional persuasiveness, logical persuasiveness, as I told earlier, were seen and tested. And the results showed that ECR performed significantly better and in enhancing the emotional engagement and responses, and it outperformed like big models like Llama 2 7B chat by around 30%, that indicating that these responses were way more contextually rich and they were way more engaging. That is, our model was able to understand the logical coherence and was more emotionally aligned over other better than other models. And coming to the engagement, our results highlighted ECR success in creating nuanced, emotionally resonant responses that really aligned well with user preferences and conversational flow. Next slide. Yeah, as for this slide, the researchers were trying to see how the model performed compared to, yeah, human baseline models. So basically, humans' responses were noted, and our model was compared to see if our model was performing at par and if not better with human annotators. That's about it. And you can see it perform better in emotional intensity and informativeness, indicating more personalized and engaging responses. Next slide. Yeah, and this is the final question that they were trying to address, with the objective of identifying the individual impact of every component, that was local entity, feedback, aware, reweighting, and global entities, as Balaji has stated earlier. And the variants that were analyzed was ECRL, that uses only local emotion aware entities. And they checked how reliable model evaluations were, and I mean, they the other the component that was tested was feedback aware rare weighting with local entities, and the findings showed that it enhanced AOC results. And as for the local and global entities, we could see that the recall was maximized, and the global entity, it was seen that the global entities provide broader context, increasing the system's relevance across diverse user profiles. And the conclusion that we got out of this was that the ablation results in the table that you saw earlier was able to enhance recommendation performance in unique ways by, capturing local, global, and feedback aware context. Yeah, that next slide. These are just a few case studies that show real examples demonstrating ECR's effectiveness in understanding emotions and providing relevant, engaging responses compared to other models. It was seen that ECR produced responses that felt more empathetic, and natural compared to, other models, and this is something that users really preferred. Yeah, next slide. This you can see that our models responses, the ECR models responses compared to other models. You can see that we have way more emotional context, and given the dialogue history between a recommender and the user, ECR perform better than GPT 3.5 Turbo and Llama 2.7B chat, as well as the corresponding evaluation results. Yeah, next slide. Again, this is another case study to test if ECR could handle unseen items and basically new items that did not correspond to the training data. And results showed that ECR could still generate emotionally aligned responses, showing its adaptability and ability to generalize well. Yeah, that's about it. Next slide. Yeah, as for our conclusion from our uh, the research paper, what we could conclude as a team, we could conclude that ECR was successfully, making recommendations that were emotionally aware, and this improved user satisfaction and user engagement compared to the other models that were out there. And future work that might in that could include in expanding ECR was to handle multiple recommendations at once, which it is not able to do as of now. And also, adapting better to different conversation contexts, enhancing its practical applications further. And in summary, I would like to say that the ECR framework is designed to make conversational recommendations more human-like, which is hard to see in the models that are present right now. It does this by recognizing and responding to emotions, improving both recommendation accuracy, as I said earlier, and to enhance the overall user experience. And each part of the system, from understanding user preferences to generating empathetic responses, adds layers of emotional intelligence that set it apart from traditional systems.